Hello Transitions to College Math class. Today we're going to be looking at section 1.3 in your notes, and we're going to be talking about exponents. Before we begin, make sure that you have your note packet with you so that you can copy things down and follow along as we go through the video. You definitely want something to write with, and I would highly recommend having a calculator. If at any time the video goes too fast or you miss something, feel free to pause, rewind, and re-watch any sections that you need. If doing so and re-watching just isn't enough, be sure to write yourself a note so that you can ask in class tomorrow. I will absolutely take and answer any questions you may have. Alright guys, let's go ahead and get started. Section 1.3, Exponents. Now an exponent is the little number we see next to a large base number. That exponent tells us how many times we multiply that base number by itself. For example, 2 raised to the third power, or 2 cubed, where 2 is our base number and 3 is our exponent, tells us that we take that value of 2 and we multiply it by itself 3 times. So 2 times 2 times 2, we get a value of 8. So 2 cubed is the same as 8. Now some basic rules that go along with that idea. Our first one, it says for n a positive integer, a raised to the n power tells us that we're taking a multiplied by itself n times. So the same idea of 2 raised to the third power, n is that positive integer, it's the exponent telling us how many times to multiply. Now, if that exponent, that n value, is a 0, something happens that's a little bit different. Zeros in mathematics tend to give us some special cases. Anything raised to the 0 power is actually equal to 1. The common error here is that students will think the answer is 0. Make sure you know that anything to the 0 power is actually 1, not 0. The only exception to that rule is when the base number is also a 0. 0 raised to the 0 power is actually undefined. This is kind of like trying to divide by 0. We can't do it. 0 raised to the 0 power is the same idea. There's no solution. The third basic rule here has to do with negatives. If our exponent is negative, this is actually indicating that we have a fraction. In order to evaluate a negative exponent, we need to flip the entire value. Instead of a to the negative n power over 1, this becomes 1 over a to the positive n power. After you've flipped the value, the exponent becomes positive. Okay, now that we've seen some basics, let's try some examples. Number 1. We have 363 raised to the 0 power. While our rule above tells us that anything raised to the 0 power is actually 1. So even though 36 is a really big value, if we raise it to the 0 power, we still get an answer of 1. Number 2. This problem is dealing with the negatives. When we see a negative exponent, remember that this should indicate to you you need to flip the fraction. So instead of 1 over 10 to the negative third, this becomes 10 to the positive third over 1, which really just gives us 10 to the third power, or 1,000. Number 3. Again, we have some negative exponents. Recall that a negative exponent, just like in number 2, will flip our value. So, a u to the negative 7th divided by a v to the negative 3rd. The u to the negative 7th will move to the bottom of our fraction. The v to the negative 3rd will move to the top. Since both of these variables have negative exponents, we do need to move and adjust both values. Alright guys, take a moment, pause the video, try numbers 4 through 6, using these same rules. When you're finished, go ahead and check your answers from the answer key on the website. Now that you've finished those three, let's look at the next page where we will get a few more rules for working with these exponents. Okay. On this page, we find out how to combine exponents if we have more than one base. On the previous page, we really just had one base number we were concerned with. So our first one, if we are multiplying two values that have the same base, as long as those bases are the same, we can combine them by adding the exponents. When we have a power raised to a power, so you see a double exponent here. In this case, to combine the exponents, we will multiply them. Division, if we're dividing exponents that have the same base, our rule for combining these is by subtracting them. Our last two rules allow us to work with exponents that have different bases. This is a times b raised to the m. Notice that we have two different variables here raised to the same exponent. In order to work with this, we can think about distributing that exponent to each of those bases. This rule also carries through for division. We've got a divided by b, both raised to the m power. This is the same as saying a raised to the m divided by b raised to the m. Alright guys, let's try a few examples. Example 1. 5x to the negative third times 3x to the fourth. The coefficients, the numbers in front of our variables, multiply normally. 3 times 5 will get 15. The x's, however, we will use our new exponent rule. Since both of these are an x, the base numbers are the same, we can combine the exponents by adding them. So negative 3 plus 4, we get a value of 1. So our answer here is simply 15x. In the next problem, we've got a division. Again, the coefficients work together as they normally would. We can divide the 9 and the 6, find a common factor, and work from there. The variables, however, will use our new rule. Since we have a y and a y, the same base number, we will take and subtract our exponents. So let's give it a try. 9 and 6 both have a common factor of 3. So we can divide each of those by 3 and get a result of 3 over 2. The variables, again, we can subtract these. We can say y to the negative 7th minus a negative 4. This will give us a result of y to the negative third. Remember that subtracting a negative is the same as adding. One final step here, we need to take care of this negative exponent. In order to be fully simplified, we like to see positive exponents. So since this y is raised to the negative third power, in order to make it positive, we'll move it to the bottom half of the fraction. Now notice that I did not move the coefficients. The 3 and the 2 stayed on the same side of the fraction as what they started on. We do not move the 3 and the 2 because they do not have negative exponents. The only value with a negative exponent is the y. So the only value that moves is the y. Number 3. Notice here that we have two different bases, so we can't subtract the exponents as we did in number 2. However, we do have a second exponent on the outside of this fraction. What we can do here is multiply the individual exponents. So an x squared times a negative 3. So 2 times negative 3 gives us a negative 6 for the exponent on the x value. We can do the same with the y's. 4 times negative 3, we will get a negative 12. Once again, in order to be fully simplified, we need positive exponents. Since both of these variables have negative exponents, we want to interchange those variables. The x will move to the bottom of the fraction, and its exponent will become positive. The y will move to the top of the fraction, and its exponent will become positive. Y to the 12th over x to the 6th will be our final answer. Number 4. 3x to the 4th, y to the negative 3rd, all raised to the negative 2nd. Again, notice we have different base numbers here, but everything is raised to a negative 2nd power. So this problem is very similar to what we did in number 3, in that we can distribute that exponent through the quantity. Do make sure you distribute completely. The 3 also gets an exponent of negative 2 added to it. X to the 4th times a negative 2nd power gives us an x to the negative 8th. Y with a negative 3rd power times a negative 2nd power gives us a positive 6th power. Once again, let's take care of those negative exponents. The 3 and the x both have negatives, so they move to the bottom of the fraction and their exponents become positive. The y, however, already had a positive exponent, so it stays on top. Last but not least, let's take care of that 3 squared. We know that 3 squared is the same as 9. So our final answer here is y to the 6th over 9x to the 8th. Our final problem in this row, or column, is 1 over a minus b to the negative 2nd. I would recommend star or highlighting this problem because this is often a problem that I see common mistakes on. This problem is not the same as number 4. We can't simply distribute this exponent because there is a subtraction. If you see an addition or a subtraction inside your parentheses, you cannot distribute that exponent. Instead, we can change this to a positive exponent. Making this a minus b over 1 squared, or just a minus b squared. Now recall that an exponent tells us how many times we multiply something by itself. So if this quantity is squared, we're multiplying it by itself twice. So I'm going to rewrite this as a minus b times a minus b. Written in this form, I think you should have a better idea of what to do. If we have a minus b times a minus b, we need to FOIL. First, outer, inner, last. So our answer, a times a squared, first times first. A times negative b, outer times outer, negative ab. Negative b times positive a, inner times inner, again, negative ab. And last times last, negative b times negative b, giving us a positive b squared. Combining like terms, we find that our answer is a squared minus 2ab plus b squared. Again, you couldn't get this answer by simply distributing the exponent. That would only have given us a squared minus b squared. But we see our answer is very different. All right, guys, take a few minutes and please try numbers 6 through 10. Use these same rules and these problems to model the process. When you have finished, once again, be sure to check your answers from the answer key on the website. After you've finished these 5 problems and you've checked your answers, you're finished with your homework for this evening. We'll see you in class tomorrow.